All right. Yeah, thanks, Greg, for the invitation. I'm glad to be here back in Copenhagen after a few years. I'll be showing you very few projects only, and probably give you something to think. This is a project that's currently underway in Stockholm, in Sweden. I'll come to that back later. That's the topping out ceremony that happened just before Christmas. Nicely under a tent. Yeah, so it was cold outside and inside also, but it was not raining there. My name is Fabian Scheurer. I founded a company that's called Design to Production about 15 years ago, which does exactly what the name says. It doesn't do any design and it doesn't do any production. It just does the two in the middle. So it translates design into production. And to be able to do that smartly, we also try to sort of inform design about production. So the idea is to connect the two as close as possible. Our claim is that we both talk and speak design and production and simultaneously translate between the two. And the overall aim is to do that on a digital basis. So what we're trying to do is build digital bridges between design and production and connect digital design and digital fabrication. We've been doing this, as I said, for about 15 years. More than 200 projects have come out of this. A lot of them are in timber, as you can see. Maybe some of them will come familiar to you. One of this is the Swatch headquarters in Biel in Switzerland by Shigeru Ban. That was opened a few years ago, 2019. You only see a small part of the building here. It's basically 240 meters long before it takes off, goes over the street, and then rests its head on the other side of the street on another building that's also by Shigeru Ban, which is the Omega Museum, because Swatch and Omega basically are connected as companies. That's the one that I've shown on the title. It's an annex to the Technical Museum in Stockholm. That is currently in build, will be opened hopefully in this year, 2023. Basically hosting a big wooden geodesic dome with a 3D cinema inside, and then you have this timber grid shell on top of it. 1,500 square meters, designed by Elding Oscarsson architects from Sweden. And this is sort of the things that we're doing. All of the projects that we've been doing are digitally designed and fabricated. All of them are prefabricated off-site, so it's basically big sort of construction kits that we're developing together with the planning teams there. 80% of them are in timber, which is sort of an accident. It wasn't planned like this 15 years ago because we wanted to go into digital fabrication, but it quickly turned out and we learned that the timber guys are basically far ahead when it comes to digital fabrication. And they're used to prefabrication because they've been doing it for a couple of thousand years, basically detailing all the beams before they hoist them up into the church. And almost all of them are pretty crazy, curvy, freeform projects, except for some. We've quickly jumped into the realm of more orthogonal buildings a couple of years ago. This is a building in Switzerland, in Winterthur, half an hour from Switzerland, called the House Krokodil. It's an 8-story housing block, 250 apartments, completely made in timber. We were working for the timber contractor there in Plenia, and that was sort of a pilot project to find out if we could play all the tricks that we've learned with the crazy curvy things over 15 years, if we could translate that into sort of the standard orthogonal realm. And I have to say, we almost failed. The building's there, it's standing, everything's fine, but it cost us a lot of nerves. And I'll try to explain why. But it also gave us a lot of answers to one question, which is, and that's always posed as, why are you only doing freeform projects? I mean, really 99.99% of the building volume out there is pretty much orthogonal. And you're coming along with all those crazy, curvy Rolls-Royce Formula One projects. Our answer always was, because we can. And it's great fun. And you get invited to conferences and can give talks. But with this one orthogonal project, we actually learned that there's a second level to that. And the second level is actually the non-standard freeform stuff is the low-hanging fruit when it comes to digital revolution in the AEC industry. Because at a building like Swatch, from the first day on, they know it can't be done with the standard things they've been used to. At a building like the Crocodile, if you start trying something new, for sure there's this one day where someone comes along and says, it's always been like that. We've been doing it for 20 years. It's never been like that. And who are you to tell me anyways? Yeah. So why try something new? And this is much easier in this crazy project, because they all know it's not going to work otherwise. So the question is a little bit, we know we have digital fabrication, especially on the timber side. It's already there. Some call it Industry 4.0. And we have digitalization on the planning side. Most of you call it BIM, Building Information Modeling. It should be actually an easy thing to just put the two things together, send the data from the BIM model to the fabricator, and bam, everything just works. In reality, it looks more like this. You have a project, and the knowledge about the project rises very steeply in the beginning and then a little bit slower towards the end, but pretty continuously. People learn about what they want to do, what they want to build. If you look at the digital information in the project, it typically looks like this. After every project stage, you throw away at least 80% of what you've built up. And then you work frantically to rebuild it at least to the level that you have been before and a little bit more than that. And that's pretty common, especially when there's a handover from the planning side to the fabrication side, because people like Greg take your IFC model, look at it, throw it into the bin and start building it again in CAD work or whatever the tool is that they're using. The question is, why is that? Obviously, there is too much information there, and most likely there's too little quality, because otherwise you would just take the thing and use it. It's a lot of work building those models. Just to be clear about that, this is not about bashing IFC or whatsoever. It's not about the format the data is in, because IFC is just a wheelbarrow to transport the bits and bytes from A to B. We're talking about a content problem. The quality is not right, not the box around it. Give you an example. Challenge number one, if you go into fabrication, you have to have the level of detail that fits what you want to do. In a project like Swatch, there's about 140,000 screws, which all need to be pre-drilled in this curvy structure, because otherwise you wouldn't find the correct place to put them. And they can be, but the question is, how do you define the position of every single of those screws in a digital model before it can be drilled by a digital machine? Because it's not there. If it's not there, the machine doesn't know where to put the drill. So you have an explosion of information that's happening at that point. And it has to be of the right quality in the end for the machine to work with. Our solution to that is that we're using parametrics. The same way as the gentleman from Lindner showed beforehand. We're starting with an abstract model that only contains the grid. And then over a few stages, we have little machines there that are not really explained that turn this abstract model into more detailed models. Until in the end, we have all the screws in there. Sounds easy. It's a little bit of work, but it's working. That means for a project like Swatch, in the end, we have about 40 gigabytes of data. About 18 gigabytes of that is actually 3D models, what you can see in renderings and other things. A little bit more, actually, more than half is data generated from that goes to fabricators, that goes to approval, 2D drawings, fabrication data, lists, Excel sheets, you name it, it's in there. The actual work is over there. It's 12 megabytes of scripts, or Grasshopper in some cases, that does the actual work and generates all this. And this is the lever that we can pull to create a full set of construction documentation for a project like Swatch with 11,000 square meters of timber grid shell and 2,800 facade elements and about 75,000 individual parts in there with 4 persons within a year. That's the trick. Problem is, it only works if you have a systematic approach to what you want to build. Because if you want to put that into rules, into parametric rules, all those 470 individual glass elements have to follow the same rules. They're all different, yeah, but I have one button to press to get them detailed. If they all follow different rules, I need 470 buttons, which are much more expensive. And this is how we do planning as of now. Yeah, you have a lot of people individually detailing things. This is not how it works. Yeah. The second challenge that we're facing is, in the end, you're having a CNC machine that is perfectly capable of and actually wants to fabricate within 0.5 millimeter tolerance. How much is that in inches? A 32nd. Yeah, and this is not just because we're in Switzerland and we have a certain fetish for precision and we actually want to be watchmaking. This is because these are structural parts that need to be connected with structural details, and the structural details are fabricated directly on that machine, and there's standards and norms and regulations that tell you that a steel dowel needs to fit into the slotted plate within 0.5 millimeter tolerance, or otherwise it's not going to ticked off by the engineer. So we need that, otherwise it wouldn't be there. Question is, if you look at your standard BIM model, is it precise down to 0.5 millimeter? Or actually, you need more than that because of a little bit of tolerance that's also in the modeling process. You need 0.05 of a millimeter in the model before you can fabricate 0.5 of a millimeter on the machine. Typically, what you get as an input from the planning stages, if you're lucky, about 5 millimeter tolerance. Yeah. And that it's also not to bash the architects and the planners, they simply don't know the details at that precision when they are forced to issue that information. So how do you get from a blurry 6B pencil model at the design stage to a crisp and sharp 6H pencil drawing model at the fabrication stage within one model without throwing it away and rebuilding it? That is the big question there. Yeah. Again here, of course, we're using parametrics. And the thing is, we cannot start with a blurry abstract model to get a crisp and sharp detailed model at the end. We have to start with a crisp and sharp abstract model in the beginning. And this is why we're taking great pain to create very slim and slender, but very precise models at the beginning that, for example, show you the building grid, where the axes actually meet in one point if they are supposed to, which is never ever the case if you get drawings from an architectural or engineering firm, because it was never asked for. Yeah, in an early stage of a building, you just drop in your axes and they're roughly where they belong, not down to 0.05 of a millimeter. Why should they? But if you want to build up on that data until the very end, they have to be. So for Swatch, we have a building grid, we have a reference surface that defines the actual shape of the building. We have the beam grid that is precisely defined, all already very early in the project. So we entered the project 2013, 2014, 2015, we had that reference geometry. 2019, we had it detailed down to production data for 75,000 parts. If you don't start over there with a good model, you will not end with a good model on the other side. Shit in, shit out. Yeah? And the challenge number 3 is you have prefabrication. So in the end, everything needs to fit together. And you have not two small parts. This is one of the smaller parts dangling on the crane over there. It's about 2 meters long. The longest part is about 16 meters long, coming out of the same machine. And they all need to fit. But once they're hanging on the crane, it's darn hard to change them anymore. Yeah? You cannot make it fit on site. Either it fits or you have a problem. The question is, a lot of the processes we're working in the building industry are following this waterfall model. Yeah? Whatever the process stages are called from left to right over time, doesn't matter. You start at the very top topic there, and you gradually dig down until you end up with thinking about fabrication and assembly 5 years into the project. Problem is, it doesn't make sense to fabricate anything that you cannot assemble, and it doesn't make sense to assemble it, to design anything that you cannot produce in the end. But when do you find out? Too late, typically. Yeah. And this is where design for manufacturing assembly comes in, a term that we actually stole from the product design industry, because those are our heroes here. Funnily enough, Swatch was one of our role models before we worked on the Swatch project, because this little watch over there that you all know managed to save the Swatch, the Swiss watchmaking industry in the 1980s, because it was cheap, cheaper than the competitors from Japan. Why was it cheap? Because it only contained half of the parts that an average watch of that type contained at that time. 52 altogether. The other 50 parts were embedded into the plastic housing. That was then for the first time possible to create with the respective machinery there. So they basically just rationalized the parts in there. They only had half the parts to assemble. Even with high Swiss wages, it was still cheaper to put that thing together. The other role model that we have is not smart parts, but smart details. This is a famous Swedish shelf that you all know. It's been in production for 50 years almost. It hasn't changed on the outside, except for some new colors. It's still 60 or 80 centimeters wide, 2 meters high, 30 centimeters deep, whatever. But if you happen to have assembled some of those over the last years, you have probably noticed that the detailing has changed. They have constantly evolved the little nuts and bolts there to make it possible for stupid people like me and you to put this thing together error-free. Because otherwise, they have a hotline somewhere in Stockholm that you call and say, this is bloody shit, I can't put it together. Take it back, I want my money. Yeah. So at one point, for example, the drilling, the diameters of the holes for the dowels and the steel parts that you have to put in started to have different diameters, because then you couldn't mix them up anymore, which would make the thing not fit together in the end. Yeah. So smart parts, smart detailing, foolproof. But that also means you have to start thinking about interfaces. If you think in modules like we have them here, you have facade elements, 2,800, they're all different, 10 different parts, different types onto that facade. And you start planning this, and then you hand it off to the two different fabricators, the timber fabricator and the facade fabricator. The last time when you have this model in your hands before they start dealing with it and building their fabrication models out of it is before that. So what do? You create sort of an interface model that says, this is a hull volume of the facade element that you have. Yeah, as long as you are staying within that volume, dear facade contractor, you can detail whatever you want. We don't care. The thing needs to work in the end. It's like in software engineering. You talk about interfaces and the black box. Yeah? As soon as you stick your finger out of that hull volume, dear facade engineers, you better call the timber guys beforehand, because they might be coming along with the chainsaw, and then your finger is off. Yeah? And the interface is exactly here for both sides, so you know where to look. Yeah? So the question is, and that's a slide that all of you have seen if you were in any BIM talk ever, yeah? It's okay, we have a traditional design process where a lot of the work is happening just before fabrication. And wouldn't it be a great idea to basically build a digital twin of our building so we can find all the mistakes and the errors that happen half a year before that, while we're still in the design stage, so that we don't find them only on site. Great idea. I would also say so. The question is, how is the work underneath those two heaps actually happening? Currently, it's basically the same thing just half a year earlier, which means we're in the same deep shit half a year earlier than we've had before. Because a lot of what we're doing when we do build digital twins is actually the same as we did when we build buildings. We pour a lot of information on a big heap without caring too much what's in there. Yeah? And what doesn't fit is made fit. And never ever does someone actually zoom out and find out where the problem is and then solve it at the root. It's just cut off. And this is why the models end up like we have them now. You look at them, throw them away. Greg starts CAD work and does a new model. Yeah? So the question is, if we are digitalizing, we should listen to that guy who's the CEO of Telefonica, who gave an interview in 2016 and said, the very interesting sentence, when you digitalize a shitty process, what you get is a shitty digitalized process. And we need to think about the processes. And we need to think about, if we want to industrialize building and fabrication, we also need to think about how do we industrialize the planning process in front of it. Because this is craftsmanship at the moment, not industry. Yeah? And how do we scale it up? Because we don't have the people to deliver all that data to all the machines that we need to build all the houses. And it's probably not going to work like that. Yeah, you just get a few new desks and more computers. You have to think about the process in there. And you probably have to think about things from the back end, which means we're always talking about pull planning when it comes to moving items. So the last one in the chain actually defines when do I need this wall element on site, and then everything goes forward until someone realizes, I have to build it now so that I will end up in the right place. In planning, we're still doing push. Someone's doing a model and then it's being pushed down the pipeline because we think he will need that information. In the end, no one's ever asking him what he actually wants. So we need to be caring about the back end of this thing and ask, what type of information do you actually want to use for your fabrication? And then create exactly that and nothing else. That would be an industrial process. So I think we should start talking to each other, design and production. And if you're afraid of that, you can talk to me because I can translate. In the end, we can do things like that. We could also do them rectangular, if everybody would listen. Quote from William Gibson I like very much. The future is already here. It's just unevenly distributed. Thank you very much.